tangent, parent function, f of x equals tangent of x. And we came up with this yesterday, correct? Because you should know your unit circle values. The tangent of 0 is what? 0. The tangent of 0 is 0. What is the undefined? Here's my unit circle, right? So this is 1, 0. That's why tangent is 0. This is 0, 1. So that'd be 1 over 0. That's why this is undefined. That's at pi halves. So at pi halves, halfway between 0 and pi, I have an asymptote because it's undefined. So this is 0. This is pi halves, right? So this is pi. So what's the tangent of pi? 0. This is 3 pi halves. Right? What's the tangent of 3 pi halves? Undefined. So at 3 pi halves, I have an asymptote. Now look around this between pi and 2 pi. Right? Well, guess what? It's halfway between pi and 2 pi. Each one of these little steps, here's pi, and I divide it into 1, 2, 3, 4 spaces, right? So we count 1 pi. Pi fourths, which is pi fourths, 8 pi fourths, which is 2 pi. Makes sense? So you think in terms of fourths out there. So at 2 pi, what's the tangent? So just let's stop there for a minute, and then let's look at pi fourths. What's the tangent of pi fourths? 1. All right, oops, I don't know why I'm up there. 1. So at pi fourths, right here, I'm up here at 1. So this is pi fourths, right? This is 2 pi fourths, and then this is 3 pi fourths. So what's the tangent of 3 pi fourths? -1. So here, what's the tangent of 5 pi fourths? 1, +1, right? So at 7 pi fourths, which is in the 4th quadrant, is what? -1. Okay. So, the pattern there. Now the fourths. So, on the other side of this one, I go down to -1. And then pi fourths over, I have an asymptote. So you have an asymptote every 1, 2, 3, 4. So it's every pi. So 1, 2, 3, 4. Asymptote. Halfway in between. And then you have your points like this. And then remember that what we know about asymptotes and graphing, we can sketch in the curve. We don't have to worry about the values. I mean, we don't want to have to. It's not necessary. We're more worried about this. Is the period pi? What do y'all think? Yes, because the period is the length of a cycle. Does it repeat every pi? Yes, it does. Very good. So the period is pi for tangent. What is it for sine and cosine? 2 pi. Okay? 2 pi, well, it's 2 pi, and then to find it from a function, or like for the parent function, it's 2 pi. And then to find it, you divide by b. So for the parent function of tangent, then the period is pi. Very good. Domain here. There's a whole lot of domain, but there's a whole lot of stuff that doesn't also. Would you agree with that? So we have to write this kind of an odd way. All real numbers, except that it's not really all real numbers. X cannot be certain things, right? What is the first thing starting at 0 that X cannot be? Pi halves, right? So it can't be pi halves. And before it can't be something pi. So this is pi away. pi, I'm going to have an asymptote, right? So that means that x cannot be pi halves plus n times pi. That's any multiple of pi, even if it was happened to be negative, right? Do you remember how we wrote this weird stuff on the other ones? Now, yeah, and there's like an e and stuff. Now remember, you're not gonna have to answer domain questions, so I don't want this to freak you out. I just want you to be able to follow and it makes sense, and you're not gonna necessarily have to repeat it, okay? But you could understand it if you read it. Where n is an element of the integers, and the integers is that weird capital Z. Okay. Now, what's the range for this tangent function? Negative infinity to infinity. We're going to change x-intercepts to zeros because otherwise we have to write them in ordered pair form, and we don't want to do that because there's a lot of them, right? So where's your first 0? At 0. And where's your next one? Pi. And then your next one is at 2 pi. So they happen every pi, right? And so that means my zeros are just n times pi, where n is an element of the integers. What's your y-intercept? It's an intercept. So what do we put? 0, 0. Good. An intercept has to be an ordered pair. All right. Asymptotes. Well, there weren't any for sine and cosine. There's a whole bunch of them here, right? Okay. So if you remember when we were doing rationals, except for the wholes, the domain and the asymptotes very much related. The reason that x cannot be these things is because that's where an asymptote is, right? So if x cannot be this, that's because the asymptote means x is pi halves plus n times pi, where n is an element of the integers. Does that make sense? These two are very related. There's asymptotes here, that's why x can't exist at those exact same spots. Amplitude. What's the definition of amplitude? It's half the distance between the min and the max, right? Do we have maxes and mins here? No. So if I don't have maxes and mins, I can't find the distance between to find half the distance between, right? So for an amplitude, it's undefined. The tangent doesn't have one, okay? And the period, we've already decided is what? Pi. Very good. For sure, yes. All right, so then let's look at the transformations. F of x is equal to a times the tangent of b times x minus c plus d. So that's everything in there right now. Today we're only going to look at the a, the b, the c, and the d will come later. Now amplitude, we just said it's undefined, right? But we're going to add a little something here. It's undefined, but but a can still exist. Now, we called it amplitude for sine and cosine, but we didn't call it that for every other transformation we've ever done. What do we call the a for the other ones? Stretch or compression, which kind? Vertical, because that's what the amplitude is, right? That's really what the amplitude's doing. It's telling you how it's stretched. So even though we call it amplitude, that's really still the vertical stretch or compression. So we don't call it amplitude because that has a definition that doesn't make sense here, but you still have a vertical stretch or compression that's important because that tells you how to graph it, and it's the absolute value of a. So it still serves the exact same purpose. You just can't use that word, basically, is what's happening, okay? Still an important number that we need, but yeah. So to find the period when we don't have a parent function for sine and cosine, we took 2 pi and divided by the absolute value of b, but this time the period is pi, so it has to be pi divided by the absolute value of b. The horizontal shift, remember they're called phase shifts in the trig world, so that's still your c, just like it has been forever, and the vertical is still d, just like it has been forever. Okay? Because they represent values. All right, anything else? We good? All right, so let's look at the next piece of paper. Oh, I'm sorry, what was your question? That's not a question, that's a statement. Go ahead. Missing important class time, but whatever. All right, this is going on 105. Oops. Page 105. So this is kind of what we've already looked at. It says the tangent function is undefined for certain values of x. Therefore, the tangent function has vertical asymptotes. Those are not new to us, but they're not on here, so draw them in because they're important. They need to be there. The tangent function does not have an amplitude. Still can have a vertical stretch or compression, though. So it says, given f of x equals a times the tangent of bx, because remember right now we're not looking at c and d. The period is pi divided by what? Absolute value of b, not a. This part right here is not even necessary because this is not how we're finding it. And when I wrote it out for the other classes, now that has now led to some confusion. So we're just, what that has to say about asymptotes, it doesn't even matter. Okay. All right. We good with all that? So let's graph. So we have this, and it says the period. So what would the period for number 11 be? Pi, because it doesn't change, right? Now, for the other ones, we had a little blank here, and we had to fill in for the amplitude. Doesn't ask me for that. However, I still have this number here that's important. So what I have here is a vertical stretch, and my magic number is 4. Okay. Then, just like the rest of them, which I know some of you still aren't doing this, is we should draw a little piece of the parent function, but just starting from 0. Even though I know it's pretty with the asymptotes, it makes more sense. It's going to be a lot easier to graph everything if you think about it starting at 0. So starting at 0, it looks like this, right? And then you had an asymptote, and then it went like this, right? And the period is pi. That way we get all the pieces in the correct spots. And if you're consistent about this, everything turns out a whole lot better than when you're not consistent. So we come in here, and for the parent function of tangent, we always start at 0, 0. There are no shifts right now, so I am at 0, 0. Then the next thing you want to do is the end of the period. The period is only pi. So from 0, I'm here at 0. At pi, I put another point. Then everything is half, half, half. Halfway in between that goes the asymptote. Okay, so the asymptote goes right there. Then halfway in between these two, right here, for the parent function is 1, but this number is determined by the vertical stretch. So halfway in between these two, I go up to 4. And halfway in between these two, I go down to 4. If those are your 5 key pieces, once you have that stuff down, you should be able to repeat everything, right? Because now I can see that there are 1, 2, 3, 4, and then I have another intercept, right? So I can go 1, 2, 3, 4, intercept. On this side, 1, 2, 3, 4. And they also happen every pi. You can look at it that way. Sometimes it's easy to tell because they're on the pi's, and sometimes it's better to count. And then you go in and just make sure your asymptotes are in the correct place. Be very methodical on how you do this. You know, one way is not necessarily better than the other. It's whatever makes the most sense to you. But you definitely don't want to get, you know, messed up and the counting or whatever. And then your points just alternate from up and down, up and down. So the good thing about these is that they're very symmetric and it's very repetitive. So if you can follow the pattern and looking at that little parent function, you can get these done with no problem. And remember, I told you, I'm not going to make you do the arrows on the asymptotes, even though technically they're lines, but they do need to be on all of the other parts. And on the ends of the graph, like if there's a point, you know, you need to make sure you have all the points on there that you can actually fit and that you end with arrows. Any questions at all? Okay. Now, I know some of you don't graph as quickly as I do, but so as long as you understand little things in yet, if it's there and you don't have any questions, then always just move on with me. You can always go back and finish them. All right, let's look at number 12. What's the period here? 2 pi. I heard that. Do y'all agree with that? How do we find it? We have to divide by this number, right? Dividing by a fraction means you multiply by the reciprocal. So dividing by 2 is this, dividing by 1/2 is the same as multiplying by 2. So it is 2 pi. Good deal. Do we have a vertical stretch or compression? No, but you still have a number that's important to you that's not really called anything because amplitude doesn't exist. One's important, right? So like that's the number I got to use. But I do have something else here. What do I have? The negative, and I got to pay attention to that. So I'm going to draw once again my little parent function, and the more you draw this, if you actually do it every time, then you'll know exactly what they are when you have to do it on a test or a quiz and you're not thinking. If you refuse to do that because you're stubborn and you just try and always look at your notes, that's why you can't do it when you get to a test or a quiz. It's not going to kill you to draw that. Okay, so we start with 0, 0, because there's no shifts, so that's a for sure thing. The period is 2 pi, so that's this point, and then this other point goes here at 2 pi. The asymptote goes halfway in between, which is at pi. Okay, everybody with me so far? The next point I would want to do is this one. This negative is going to reflect it in the x-axis, so instead of being above the axis, it's going to be below, and this number here tells me how far. So halfway in between these two, I'm going to go down 1. And then halfway in between these two, I go up 1. Everybody good with that? Ask me questions if I lose you or if you've got a question. Oops. It does, I know. Yeah. It'll be fine. You'll live. And so just like any of the other transformations we've done, this 1/2 here it's a horizontal stretch, and that's what happened. Your graph got stretched out. Okay? Questions? All right. Let's look at 13. What is the period on 13? Pi divided by this, which is pi halves, right? We don't have an amplitude, but I have a vertical stretch of 5/2, right? And there's no reflection here. Draw my little parent function. And then start with 0, 0, because there's no translations. That's this point. The end of the period is at pi halves. That's right there. Halfway in between those two is the asymptote, which is right here. Halfway in between the intercept and the asymptote, I have to put a point, which for the parent function is at 1, but since this is 5/2, halfway in between I actually go to 2.5, so it's right there. Halfway in between here, I go down to 2.5. There are your 5 key points. So if you look at just the x-axis right now, you can see you have point, asymptote, point, and that's going to continue. Right? Then I have an asymptote, and then a point, and then an asymptote. No, just do it. See, the good thing about this is at least it is repetitive and it's not like something different every couple of units. You just have to repeat it over and over again. The fact that that graph repeats makes them what kind of graphs? What's it called? Starts with a P. Periodic. That's why we call these the periods. That's why magazines are called periodicals, because they happen periodically, every now and again. Yeah. Learn to answer my questions. All right, so I know some of y'all are still drawing these, but let's go ahead and do 14. You can come back and finish this if you need to. What's the period on number 14? 3 pi over 2. Exactly, because you just multiply by the reciprocal, right? We have a vertical stretch of 3. Here is my parent function, just like this. Okay. So, start with 0, 0, because there's no translations. End of the period is 3 pi halves. Is that an easy number to find? Yes, it's halfway in between pi and 2 pi, right? So here's 3 pi halves. So think about this without your brain exploding. What's half of 3 pi halves? Half of 3 pi halves. 3 pi fourths, right? Because it's multiplying by 1/2, right? Okay, is 3 pi fourths pretty easy to find on here? Yes, because you count 1 pi fourth, 2 pi fourths, 3 pi fourths, right? And this is where your, yeah, it's like 1 teddy bear, 2 teddy bear, 3 teddy bear, exactly. So that's all it is. You don't make it harder than it is, okay? Then halfway in between these two, there's not a reflection, so it's going to be literally halfway here, and you go up to 3. Halfway in between these two, go down to 3. And then you repeat, right? So you've got 1, 2, 3 pi fourths in an asymptote, then 1, 2, 3 in a point, then 1, 2, 3 in an asymptote. Keep going in that pattern, and you'll be good. All right. Questions? We good? You got tangent down? Okay, if you don't have any questions, once you finish this, then you got 4 problems on the back of that worksheet to finish. You should hopefully be able to get it done. You can turn it in before you leave. Okay? No questions? Awesome. Yep.